Hi, my name is Denzel Carter, and I'm going to be presenting Lab 1 on charge tapes. So the purpose of this lab is to learn how to use everyday objects like tape to model excess charge, and also to use GlowScript to model real-life experiments. I'm going to be observing the physical properties of charge and the force due to gravity, and making estimations and assumptions. So the fundamental principles that I used in this experiment were Coulomb's law and Newton's universal law of gravitation. I also used some constants like the charge of an electron and the length of an atom. So the procedure to make this experiment, you start off by making a U-tape by applying a base tape down on the table, and then creating an upper tape by folding the end of it and then ripping it off from the base tape to take the electrons and leave them in excess on the upper tape. The next part of the experiment is to observe the interactions that the charge tape has with different objects. So the first interaction you're going to try is using your hand to see if the tape is attracted to your hand, then that means that it's charged, and if not, then that means you have to remake the tape. Then you're going to bring two upper tapes close together, and if they repel, that means that they're the same charge, and if they attract, that means that they're different, opposite charges, or one of them lost their charge. Then you're going to bring a neutral item like a book near the tape, and it should attract because the neutral atoms in the book should be polarized by the tape. Finally, you're going to rub a plastic pen against cloth, which should make it negatively charged, and then bring it to the tape to determine that if it attracts, then that means the tape is positively charged, and if it repels, that means the tape is negatively charged. The final part of the experiment is to get an upper tape B to float by placing tape A close underneath. Once the tape B begins to float, you measure the distance between the tapes. So the observations I made were that the tape was attracted to my hand, and that the two upper tapes repelled each other, which means that they were the same charge. And I also found that the tape was attracted to the neutral book, which should have happened regardless of the charge. And I found that the tape was repelled from the negatively charged pen, which means that the tape should be negatively charged or have excess electrons. From the floating tape test, I observed that I got the tape to float after bringing it 2.3 centimeters away from tape A. Since tape B was at rest while floating, that means the net force on the tape B was 0, so that force due to gravity should be equal to the electric force due to tape A's charge. So here are the calculations I made. To find the mass of the tape, I found that the tape was 2 times 10 to the negative 4 kilograms. The gravitational force I found to be 1.96 times 10 to the negative 3 newtons. And the charge on tape B I found to be negative 1.1 times 10 to the negative 8 coulombs. So the number of excess electrons I found by taking the charge and dividing it by the charge of an electron, and that gave me 6.875 times 10 to the 10 electrons in excess. Then I found the number of atoms on the surface of tape B by dividing the area of the tape by the area of the atom, and I found there to be 4 times 10 to the 17 atoms. And then I divided these two numbers to find the ratio of electrons to atoms. And to find these numbers, I did make some assumptions on the charge being uniformly distributed on the tape, and also that the atoms were not, that the area of the atoms did not collide at all. So here's my code from GlowScript. So on the picture on the right, you can see the two spheres I made of tape B, which is the red sphere, and tape A, which is the lower sphere. Tape B having equal and opposite forces of the electric force due to A on B and the force due to gravity, and the tape A having the force due to the electric charge from tape B on A. The charge that I got from GlowScript on tape B was negative 1.07 times 10 to the negative 8 coulombs, which is pretty close to my hand calculations of negative 1.1 times 10 to the negative 8. So some assumptions that I made while using GlowScript were that I ignored air resistance and resting tape B on the two books on each side. And I also should have included on here that tape A had the force due to my hand pushing up, which would be equal to the electric force. So I also treated both tapes as point charges to simplify calculations, and I also assumed that both tapes had equal charge, although this was probably not likely. So here's the rest of my glow script code. On the left, you can see my constants, which I made some of them able to be changed easily, like the tape length, so I could measure different scenarios. And on the right, you see my calculations, where I measured different things that I measured before, like tape mass, force due to gravity, the tape area, and the ratio. Here is how I made the visuals for my glow script code. And here's some of my final reflection questions. So if electrons had positive charge and protons had negative charge, I found that this wouldn't really affect my experiment very much, because the physical principles of likes repelling and opposites attracting would still apply. So most of the interactions would still be the same, and the tapes would still repel each other. But if the pen was still negatively charged, then in this case, the tapes would be attracted to it instead of repelled. And the final question of why it's important to handle the charged tapes as little as possible. The charge from the tape, once you start handling it, will want to find its way out of the tape and ground itself onto your body. And basically, the sweat on your body acts as a conductor for the charge to go from the tape and onto your body and spread out as much as possible. So that's it. Thank you.